Today we are going to be solving two-step equations. And solving an equation, it doesn't matter what type it is, whether it's two-step, multi-step, or one-step, it's like undoing or unwrapping a present. And so there's some operations that are covering up this unknown, which is inside the box of a present. Well, here we are having to take away 8 from that and multiply by 3. So we need to undo those operations to be able to figure out what the unknown is. So the first step is to do the opposite of negative 8, which is going to end up being positive 8. So I'm going to end up adding 8 to both sides, and what that leaves me with is that 3x, and this all equals now 12. So to undo that multiplication of 3, I'm going to divide by 3 on both sides, and that will leave me with x equals 4, and that would be my answer. Well, for the next one, same sort of thing. We've got this two-step equation, and things are covering up the unknown that makes it so we don't know what it is. They subtract by 4 and divide by 2. So we're going to undo those by doing opposite operations. So I'm going to end up adding 4 to both sides. And what that leaves me with is this x over 2 equals 30. And so from this point, now we've got a division problem that is covering up the value of x. Well, what we'll do to solve that is do an opposite operation. I'm going to multiply by 2 on both sides. So what that leaves me with is this x all by itself, and it equals 60. And now we know what x is. So on the next one, same sort of thing, except this time we've got to move terms to the left-hand side. So we're undoing the operations that are covering up the value of x by doing opposite ones. So I'm adding 1 to both sides to start with. So it leaves me with 15 equals 3x. So to solve from this point, I'm just going to divide by 3. And so when I do that, I'm left with the value of x. X equals 5 in this case. And that is our answer. So in the next problem, a little bit more difficult, more negative signs. So we're undoing it by adding 2 to both sides. Now notice when I have a negative 32 and a positive 2, I need to subtract these two numbers because they're opposite in sign. So we're left with 5t now equals a negative 30. So from this point, just divide by 5, and we'll have our answer. So here we have negative 6 equals t. Looking at our next one, we're doing again some opposite operations. What makes this one more difficult is the coefficient, the number out in front of x. So once we take that 5 away from both sides, and again, you got to take 5 away because this is a positive 5. So in order to get rid of it, we're taking 5 away. We're left with a negative 2/3 x equals negative 16 because we're adding because they're the same sign. So when we go ahead to get rid of this term, I'm going to multiply by the reciprocal. I want to use that additive or multiplicative inverse to make it 1. And that's what I'm doing here. So the negative signs will cancel, the 3's cancel, the 2's cancel. But what I do to one side, I have to do the same thing to the other. So think of that as negative 16 over 1. Do some cross-canceling to see what's left over. 2 goes into 16 8 times. Multiply across, we've got our answer. X equals 24. Remember, the negative signs will cancel there. Same sort of thing on this next one. We're going to subtract 6 from all sides. Notice again, we've got the same sign on the right-hand side of that equal sign. Same sign there, so I'm going to add. I get negative 21 equals 3/5 x. So we're going to do the same thing. We're going to do an opposite operation and to undo this, but what we'll do to do that is to multiply by the reciprocal. And that will cancel the 5's, cancel the 3's, just leaving us with x. But what you do to one side, you always have to remember to do the same to the other. And so when I do this, I'll treat that negative 21 as a rational number just as it is, putting it over 1, so I can divide 3 into 21 to make 7. Left with that negative 7 is going to be multiplied by the 35 to give me my final answer of negative 35. And that equals x. So those are the regular type of problems. Then we also have some word problems that will go along with the homework. And here's one where it says Paul bought a student discount card for a bus. And the card costs $7. Now this right here costs $7. That means that's already been done. This is like a starting point. And from there, Or we can even consider this like a constant. That's what we would call this, because nothing's being multiplied by that number. So the $7, and this and tells us that, okay, there's something else. That means we're going to add something to it. And allows him to buy bus passes for $1.50. So he can buy these bus passes for $1.50 each. And so it's like one bus pass costs $1.50. So if he spends $7, he gets a discount from the bus, which is now only $1.50 opposed to whatever else the bus would have charged. So after 1 month, Paul spent $29.50. This is a total. This is what it equals. And so let's go ahead and try to set up an equation. We have, I'll just try to write it out first. I've got a changing amount, so a variable amount. And the variable amount is the unknown amount. And that's the amount that the daily bus passes we bought. So the bus passes purchased. So this is a part we are not sure about yet. And we're going to figure out what this is. And so after that, we're going to add on a constant amount. The constant amount is the amount that we started with. Remember, we had a starting point? That was the card cost. The discount card, that's what we spent. And then it's going to equal a total, the amount we totally spent. So this is a two-step equation, just like these were up here. Notice how we have a variable amount, we have a constant, and then we have a total. So it's the same sort of thing. So our variable amount is always the question. So it says, how many bus passes did he buy? Well, let's do this. Let's call, how about daily passes? We'll call D. That's our variable there. So we know that they cost $1.50 each, times by the number of passes we purchased, and then we're going to add on the card cost, $7, and it equals $29.50. That's what we spent. So now we're ready to solve. So the way we're going to solve this is opposite operations. We're going to take away the amount of the card cost, and that will give us just the amount that we spent on daily passes. So now we've got this 150. I'm going to change that to just 1.5 now. 1.5D equals, and this makes 2250. So I'll just write 22.5. So now we're ready to solve. So what I'm going to do to solve this one is I'm going to just divide by 1.5. Divide this side by 1.5 as well. And so let's go ahead and see what happens. So I'm doing 1.5 into 22.5. And so I need to move that decimal over, move this one over. And so I bring that up. 15 goes into 22 one time with 1 left over. And so we go ahead and do the subtraction. Borrow a bit, and that makes 7, so 75. 15 goes to 75 5 times, so 15 is the answer. So D equals 15. So 15 passes is what we ended up purchasing there that month. Now the next problem talks about how Linda has 12 records in her collection. Okay, this is a starting point. So just like the last one, we had a card cost $7, $7. That was the starting point. Here, this is our starting point. And so from there, that would be our constant. So our formula is going to have a constant, a variable amount, and a total. And then it says she adds the same number of new records to her collection each month. And so we don't know what that amount. Same number of new records each month. After 7 months, Linda has a total of 26. Okay, this is a total. This is what we end up with. So that's what it's going to end up equaling. So what we're asked to do is find out how many records does Linda add each month. This is the question. This is going to be our unknown. Let's go with, how about R for number of records? This is what we don't know. But we do know she does it for 7 months. So it's going to be, we have a variable amount again. We've got a constant that we're going to add on, and then we've got equals a total. So let's try to set up our problem. We've got 7 months times the number of records. Oops, we didn't use D this time, we're using R, so let's change that. That was last time. So 7 times the number of records plus the constant, which is the amount that we started with, the 12, and it's going to end up equaling a total of 26. So now we're ready to solve. So the way we're going to do that is just opposite operations. So I'm going to take away the 12 from both sides. So what I'm left with is this 7r equals, do some subtraction there, that makes 14. So now I'm ready to divide by 7 on both sides, and that gives me my answer of r equals 2. So 2 records. That's how many she buys each month. Well, those are types of problems that you're going to end up seeing on tonight's homework. Good luck.